Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Ahmad Kamal Huzipi Muhammad Kamal. Matrix number DE220067. Okay, now we will be presenting about the on-grid photovoltaic system for the power electronic projects. Okay, here are our group members. From the left, Muhammad Fakir Haziq bin Azman, Ong Yu He, Loh Wei Kiat, and me, Ahmad Kamal Huzipi. Moving on. For this project, the photovoltaic system or GCPV, grid connected photovoltaic system, is used to have solar energy, particularly for areas without access to a centralized electrical grid. An inverter is needed to convert this DC energy into an AC energy, which are suitable for powering the household or industry loads. For this project, the designation for our input voltage is 300 volt with load consisting of resistance 10 ohm and an inductance of 0.6 millihenry. Okay, that's all from me. I will pass on to the next person.
This is the design and calculation analysis of our project. This analysis of an on-grid photovoltaic inverter is a crucial step in ensuring the performance, efficiency, and compliance with power quality standard. The inverter design is a voltage source inverter (VSI). Its function is to convert DC voltage input into AC output, and is widely used in solar PV system, just like in our project. So, its simplicity and high efficiency and great ability to generate high quality output is the reason why we choose it. So this is a calculation analysis of the formula we use in this inverter design. So the modulation index M is used to determine the inverter's output amplitude. The second formula will show the output AC voltage of the inverter. The third formula will be used to calculate the total harmonic distortion in the output waveform. The fourth formula will be used to cut off the frequency of an LC filter used to reduce the harmonic in the output. The fifth formula will be the total impedance load effect in an RL circuit. And then lastly, the efficiency of an inverter in terms of power will be calculated with the last formula.
Our methodology to design inverter will focus on THD using Simulink MATLAB. First, we define the parameters required for inverter. Then we decide the DC-AC topology. We use SPWM. Then we conduct simulation in Simulink. After that, we test circuit using fast Fourier transform (FFT). Next, we troubleshoot the problems in the circuit. We adjust switching frequency, filter component, and load. After that, we achieve optimal performance inverter with THD around 0.07%.
Okay, so actually, we have two part here. The first part is the SPWM for bipolar. Okay, and in this bipolar SPWM, we have two reference signal. Okay, which is the two sinusoidal reference signal lah, and then one triangular carrier signal. So in this technique, the reference sinusoidal signal will be continuously compared with the carrier signal, and then the output will get S21, S22, S23, and S24. Okay, and then for the second part here, okay, this is the single phase full bridge inverter. Okay, then the DC input here we set to 700 volt, and then the S21 and until S24 the output signal will be assigned to each of the MOSFET here lah, to turn it on. Okay, and then at first we use the quasi square wave because we want to eliminate the third harmonic to reduce the THD value. But okay, and we also add the filter here, the inductor and also the capacitor lah. Okay, act as a filter to minimize again the THD value. But we still got around 5 to 6%. Okay, okay, in order to minimize again the THD value, that's why we use the bipolar SPWM here. Okay, after installation of the bipolar SPWM, finally we got the THD value around 0.07. Later I will show the waveform and also the THD value. Okay, so there are three output here lah. The first one is the bipolar SPWM waveform. Okay, the upper one is the carrier signal, triangular carrier signal, and then the below one is the reference signal one and reference signal two. Okay, which is the impulse form lah. Okay, it used to turn on the MOSFET lah. Here's the sequence. And then we also show the output AC voltage waveform and also the AC current waveform. Okay, you can see here the waveform is looks like a sinusoidal, which is a very perfect one, because with the THD value data I show you is only 0.07. And then this the THD value for current and also the voltage. So both we can got the THD value around no approximately 0.07%, okay, which is very low, so we can get a perfect sinusoidal waveform for current and voltage. Okay.
The conclusion is on grid PV inverter designed using a single phase hash bridge topology with SPWM effectively converts DC to high quality AC output. Second, integrated LC filter ensures minimal total harmonic distortion THD of 0.07%, achieve power quality standards. Simulation demonstrate efficient handling of resistive inductive loads, confirming the designs good for PV energy systems and practical use.